Hello everyone, you're welcome to Network Pips. So still on the network fundamentals, today we'll be looking at the Ipv4 address and looking at the different classes of addresses that we have, what a network ID is and a broadcast ID, and also understanding what a subnet mask is and a default gateway, and also why we need these addresses on our networking environment. So an IP address, most of us must have been hearing about this IP address. Maybe some of us reach out to our IT guy in our organization, and the guy asks you to, oh, please, can you provide your IP address for me? And you give him something like this, 192.168.maybe1.1, for example. And to you, this does not make any sense, but to that guy, it makes a lot of sense. But let me give you an example of why we need this guy. Let me say this fine handsome guy over here, let me say his name is Ebuka, and he wants to go to his friend's house over there. Maybe his friend is staying at number 2 Badagry. Ebuka does not know how to get to Emeka's house if Emeka does not give Ebuka his home address. The same as Emeka will not know how to get to Ebuka's house if Ebuka does not give Emeka his address. So if I'm to relate this thing to a networking world, if I have a PC here, I have a PC here, this PC will not be able to communicate to each other. This guy will not be able to communicate to this guy, and this guy will not be able to communicate to this guy if they does not know each other's address. So it's safe to say that an IP address is a numeric identifier that is assigned to each of these machines on an IP network. So having said that, let's dive deep and see furthermore what this IP address looks like. So this IP address is equivalent to this over here as well, these binary numbers you are seeing. So but the thing is that this is more human readable than this, but this is what computer loves seeing. So this is safe to say that an IP address is a 32-bit 4-octet binary number separated by periods. Why is it 32 bits? If you count each of these, if you count the total of these binary numbers is 32, and each period contains 8 binary numbers, which is octet, and this period is just only 4. 1, 2, 3, 4. So you see how this definition came about. So an IPv4 has a total number of address of 2 raised to power 32. That is 4 billion number of address. It might seem enough, but in today's world, this address is not. We have a lot of things consuming our IP addresses now. Maybe like we'll now be hearing words like Internet of All Things, IoT. You see your watches having an IP address. Even shoes now has an IP address. Your phones have an IP address. Maybe one person might be consuming only let me say 10 IP address, depending on the number of gadgets that you have. So this address is not that enough again. It's exhausting. That's why we now have what they call IPv6 address. That is coming up later in this course. We're still going to discuss about that one. But let's see how we can convert this address, this our decimal value address, into this binary, because we'll be needing it in breaking down these addresses into different subnets as well, and also for exam purpose. So we are going to be using our magic table over here to determine that. Magic table is nothing, it's not that so magical. You just double add each value to get the next value. So if I do 1 plus 1, I'll get 2, 2 plus 2, I'll get 4, 4 plus 4, I'll get 8, and so on. So let's start from 192. I want to convert 192 first to get this value over here and see what it's going to give me. So if I look at my table, I will ask myself one question: what is the highest value on this table that can minus 192 without giving me a negative value? So of course it's 128. So if 128 go through 192, it's going to give me 64 as a remainder. So I'm going to add 1. You understand? I'm going to add 1. Then if I'll ask myself another again, which of this value, which of the highest value here that can go through 64, which is the remainder, without giving me a negative value? Of course it's 64. You add 1 and the remaining what? 0. So you make the rest 0, and that's how this value came about. So if I'm to do the same thing for this guy as well, 168, I'm going to look at the highest value on my table that can minus 168 without giving me a negative value. What's the highest value? 128. If 128 go through, it's going to give me remainder 40. So I'm going to add 1 over here. So can 64 go through 40? No, it's going to give me a negative value. So 64 cannot go through. I add 0 to 64. So what can go through? 32. 40 minus 32 is going to give me remainder 8. So remainder 8, I add 632 can go through. I add 32 1. 16 cannot go through. We add 16 0. Then remainder 8 can go through. We add 8 minus 8 will give you 0. You add 1. Then the rest will be 0. Then what is the remaining? 10. Okay, I'll look at my place value again. Which of the highest value here that can minus 10 without giving a negative value? Of course this 8 is out. 128 is out of it. This guy out of it. This guy out of it. This guy out of it. So I'm going to give this guy 0 0 0 0. Remaining 8 can go through. So 10 minus 8 is going to give me 2. I'm going to add 1 to 1 here. Then this guy can 4 minus 2 is going to give me a negative value, so I'm going to give 4 0. Then can 2 go through? Yes, it's going to go through. Add 1, then minus the rest will be 0. Then remaining this 1, so can you want to convert this one into binary? You say every other one will be 0 apart from this one, which is 1. Oh, the value here is wrong. So here is going to be 0 0 0 0 0 0 1. So here is 1, this guy is 1, and this guy is 0. So please correct that. Okay, so we have our subnet mask. Our subnet mask is basically a 32-bit binary number that separates our network ID from our host ID. Now, take out 2 words from it: the subnet ID, the network ID, I mean to say, and the host ID. We have our network ID, and also we have the host ID. So the network ID is what uniquely identify each host on the network. I will go again. The network ID uniquely identify each host on the network. Let me take, for instance, let me give you a scenario. Let me say they have Masters Academy as a school. Masters Academy, what uniquely identify them is their school uniform and their badge. This is what you know that, oh, this guy is a this student is a member of this school. The same way, if you go to maybe Oshodi Primary School, you see that Oshodi Primary School have a uniform, and maybe they have a badge as well. And that badge tells you, oh, this guy, you are going to Oshodi Primary School. You understand? That's what uniquely identifies them as a student of that school. So that's way, if you come to network environment, there is a specific bit that uniquely identifies each host as a member of that particular network. So let me take, for instance, anywhere you see this. So to determine the network ID of this particular IP address of this host, for an instance, you will see anywhere this 255 stops. That's what will be the network ID. So this 255 stop at the third octet, which is this 123. That's 123. So that is 123. You understand? The bits 123, 123. So it's safe to say that I can draw it like this. So down here is the network ID, and the remaining bit here is the host bit. We can call it the host ID. So the same thing here, network ID. This one is the host bit. So that's how you determine. So the network ID uniquely identify each host on the network. The host bit is what you assign to these users. So no user or no host machine will be assigned this network ID address. So the network ID is usually the first address on that network. So the first address on that of this network is 192.168.10.0. On 10.0, that's the first address there. It's not going to be assigned to any host on your network. It's meant for identifying the device, each host that is on that network. Another address you should be aware of is the broadcast address, broadcast ID. Now, this broadcast ID is used for communicating. It's not going to be assigned to any host or any device on your network as well. It's usually the last address on that network. So this last address on this network is going to be 192.168.10.255. Understand? The last address is always 255. That's always the last address, and that's the broadcast ID. It's not going to be assigned to anybody on that network. So it's used for communicating to devices on that network, sending a broadcast messages to devices on that network. That's what that ID is used for. So it's not going to be assigned to anybody as well. Now, our gateway is an address. It can be any address. It must not be 192.168.10.1. You understand? But they usually pick the first valid address on that network just to make it as a gateway. So our gateway address is more like an exit address that takes us out from our local network. So I'm going to say, let me say we have two different addresses. For example, I have 192.168.10. Let me say 2, for example. Let me say 2, for example. 2. Then I have another address. let me say this address is 192.168. Let me use a different address entirely. Let me say this guy is 10.10.1.2. It's clearly that these two addresses they have two different network IDs, so they are on different networks. So if host that is on this network wants to communicate to host on this network, they are going to need what they call a default gateway to make them to communicate to each other. So default gateway is going to route you out from your local network to a different network. That's what a default gateway address. The default gateway address must not necessarily be one, but it's always recommended to make it your first valid address of that network, or the last valid address of that network. So that's about that. So we have different classes of IPv4 address. We have class A. Class A address is going to range from 1 to 126, and it's going to have a default subnet mask of 255.0.0.0. Then we also have a class B address, which is going to range from 2 and the 122 to 191, which is going to have a subnet mask of 255.255.0.0. Then we have an address, class C address, which is 192 or down to 223, which is going to have a subnet mask of 255.255.255.0. So we have another one, class D, which is going to range from 254 to 239, which is reserved for multicasting. Going to learn what a multicasting is later on in this course. Then we also have a class E, which is 240 to 254, which is reserved for experimental purposes. So the difference between these addresses is how many valid addresses that are on each class. So for class A has the highest number of address on it, followed by class B, then class C. To determine the number of address on this network, like I already told you, you are going to count the number of hosts of the host bits of the host IDs. For example, you know that this one I stated here early, this is the host ID. So the host ID is also like this as well. If I'm counting, this is 1 2 3 4 5 6 7 8. We're going to do it 2 to the power of 8. Sorry about that. We're going to do it 2 to the power of 8. So to determine the number of valid hosts that we have on that network. So, but we're going to learn how to do that later on when we get to the subnetting class, and you appreciate that. Or I know some of you might be saying in your mind, why this guy skip the skip 127? You can see 127 is reserved. It cannot be assigned to any host or any device. It's any address starting from 127 is reserved. It's going to be used. It's a loopback address used for testing and troubleshooting. Yeah. Then we also have two types of addresses in each class. So we'll have our private and public addresses. Our private addresses are addresses that cannot be reachable over the internet. These addresses, you can never see them on the internet. The internet is the public space, no man's place. Everybody's there, but these addresses they are seeing, like when it comes to class A now, you're going to see the address ranges from 10 to 10. You can see it. So from 10 to 10 is class A. For class B, it's going to range from 172 to 16 down to 172 to 131. That's class B private IP addresses. Any address within this range, you're not going to see it on the public network. Then we also have 192.168 down to 192.168 addresses. Any addresses that you see here is not routable over the internet. So for example, let me quickly if these addresses, if users bearing these addresses, let me say this, you have a user here bearing maybe 10.10.10. If time he wants to go to the internet, is going to have what they call NAT to translate his address to a public network. Let me bring out my this thing and show you what a private IP address looks like. If I do IP config, you can see this address you are seeing here is more like my public address, my private address, I mean to say. This address cannot be routed over the internet. And to see your public IP address, you just need to type what's my IP address and your public address. You see your public address. Let me show you what a public address looks like. So any addresses you are not seen within this range is regarded as public address. Okay, so to determine your public IP address, you go to your browser, you can type let me say what is my IP address, for example, and you're going to see your public address. You can see your public address. So that's about that. So with this, we'll come to the end of this video. I would like to thank you for watching, and please see you in the next video. Thank you.